So my name is Georgia. I am currently in my junior year at FIT. I am studying textile development.
My name is Katie. I am a year removed from graduating with my PhD in biomedical engineering, and my scientific background is largely in the synthesis of biomaterials as well as cellular biomechanics.
Awesome. So, Georgia, can you tell us a little bit about your project and why you decided to focus on this jellyfish in particular?
So my project here at Genspace was focused on eventually creating a hydrogel for agricultural applications using collagen from jellyfish. One of the reasons we would use collagen from jellyfish is because that would create a hydrogel that would be hopefully biodegradable, but also because jellyfish are an invasive species in large parts of the world, and it's kind of this excess opportunity.
Katie, can you tell us a little bit about what hydrogels are and what they are used for?
Absolutely. So a hydrogel is basically a soft biomaterial comprised of a hydrophilic or water-attracting polymer that has a strong propensity for retaining water. And their applications are pretty wide range. They're almost limitless, honestly. Most of the ones that I'm familiar with are hydrogels for medicinal applications, such as plant-based hydrogels for spinal disc repair or injectable soft tissue repair. In my graduate school career, I also spent time using more synthetic hydrogels for experimental modeling of cellular biomechanics in various different disease states. But over the past 2 months now, I think it's been really exciting to learn more about their applications outside of use in cellular experimentation and medicinal applications, both in environmental sustainability and agriculture, as I've been helping Georgia with her project and reading a lot more about this realm of materials that I really had not been experienced with before.
Georgia, can you tell us about how you would want to apply the hydrogels that you would make down the line?
So mainly they would be used in agriculture. I think my initial idea was using it kind of as a way to use less of our drinking water when farming. It's about 40% of our clean water goes to our agriculture, and if we can introduce something like a hydrogel that would allow us to limit that, but still kind of benefit the growth of, especially when it comes to things like food. I think also in terms of just growing up in New York City and urban farming, a lot of our soil, might be high in iron, or it's depleted of a lot of its nutrients. So creating something that we can put into soil that would give it structure and kind of these mechanical benefits, but also maybe possibly eventually slowly introducing nutrients back into that soil to benefit the growth, to make farming more accessible for everybody.
Awesome. So you guys have spent quite a bit of time together in the lab. It's been amazing to see. What kinds of lab techniques did you use? And Katie, what role did you play as a mentor in teaching some of those lab techniques?
Sure. So we had a list. Because we had to sit down and go, what have we actually done? So we had pipetting was a big one, learning a lot about the first and second stop on a pipette, which is something some grad students didn't even really understand when I worked with them.
Molar measurements, creating solutions,
pH measurement and solution pH adjustment. What else have we done? Dialysis.
That was very exciting. Experimental design, kind of learning to really what Katie helped with also is kind of translating research papers. There's a lot that happens when you're reading these kind of documents that they're using very technical terms, and it's either you're Googling every other word, but with Katie here, she was really able to just guide me and really mentor me. She's like the best. But yeah, what else? Also piecing together parts of experiments and kind of reading through a paper and finding what we need, what we don't need, what we can expedite given our time frame.
Yeah, that was a big thing. I think that's what my largest role has been translating some of these more complex academic papers, trying to piece them together, because some of these protocols, because not enough people are talking about jellyfish or using them.
People are talking about jellyfish.
They're not talking about them, using them experimentally. Some of these protocols are, quite frankly, hard to follow because they're not giving us precise measurements or time frames for a lot of these protocols, and also given our own time constraints and just limitations of the budget and just the materials that we have on hand, trying to figure out a way to adapt these protocols to be able to get her product done to the closest approximation we can in this, what was it, 2 months we had?
Oh my gosh.
Yeah.
And what did you learn about protein extraction, Georgia?
Well, I learned what protein extraction was. I think coming into this, I haven't had really any lab experience, and I think a lot of what I was coming into is just what I've read. when I first thought of like protein extraction, I kind of thought like, oh, like just extracting the protein, with a needle maybe. I didn't know how it works, but really what it is it's kind of you're removing everything else, and kind of like you're looking at something, you're looking at your source material, which really can be anything. For us, we use jellyfish, and the fastest way to get it was kind of shopping around. And so I went to a couple fish stores and try to find these jellyfish. But it can really just come from, protein can come from anything, and science really is accessible.
All right, Georgia. So you have a few more months with us. We would love to hear a little bit about how you're going to expand this research in the future.
So next steps would be applying it and creating a hydrogel from that. We would then be testing its mechanical strength and properties, seeing how does the jellyfish collagen impact those hydrogels. We'd want to see when it decomposes, what does it leave in the soil, how long does that take. We'd want to see the structural benefits it has to the soil, as well as just how long it takes to release water and then maybe reabsorb water from rainfall. We'd also maybe want to see, can we add nutrients to give it back to the soil, and kind of just testing further.
Awesome. And Katie, just one more quick question.
Yeah.
When you have a protein, how do you turn it into a hydrogel?
That is a complicated question, actually. But I know for a large part that the creation of hydrogels, most of my experience has been with chemical cross-linking. But I think that when you're making a hydrogel out of just, like if you were trying to make a just collagen-focused protein, you could do maybe more of a mechanical cross-linking process. But basically, the long and the short of it is you need to pick if you want to have just a protein-based gel, or if you want to have some sort of base alongside that protein, whether it be a PEG, or in the case we're thinking about sodium alginate, and then how would that impact the final results of the experiments that Georgia wants to build upon, and then how do you then cross-link those two materials to make them stay together long-term? That way they're not just in a floating solution and they don't want to bind to one another. So,
I lied. I have one more question. How would you describe your experience at Genspace over this semester, Georgia?
Honestly, it's been amazing. I think it's just been a fun place to come to, and I think I've been able to meet so many people from there's not just one type of person that comes here, so I think it's pretty amazing. Like, there's people from all sorts of fields at different stages in their career and in their education, and everybody's coming here to learn. I think, honestly, like, this has really just given me an opportunity to learn also more about myself and what I want. And kind of, thinking about, I'm in my junior year of college, like, where do I want to go after this? What do I want to explore? Kind of like figuring more about myself too through this like learning environment. And that's just been amazing.
Awesome. Thank you guys so much, especially for all your hard work. It's been a joy to have you guys here.
Thank you.
thank you.